All right, guys, today we are going to talk about a man named Newton and his laws of motion. So he has 3 laws of motion. We apply those laws to our everyday lives, and they are always true. We're going to do a lot of fun things with these laws, so it's kind of important that we know what's going on with them. So let's talk about each of his laws. So Newton's laws of motion are also known as the laws of inertia. Or Newton's first law of motion, Newton's first law of motion, there we go, is also known as the law of inertia. So that law says an object in motion stays in motion and an object at rest stays at rest unless an unbalanced force acts upon it. So if I have a coffee cup and I set it on the desk, it's not going to go anywhere. It's going to stay there forever unless a force blows it over. Wind could blow it over. I could push it over. Those are all different forces. It's saying an object that's moving is going to keep moving. It's going to keep sliding until an outside force acts upon it. That outside force is usually friction. Friction is usually what stops that motion from sliding. Inertia is the tendency of an object to resist its change in motion. So sometimes it takes a lot for an object to overcome inertia. It's really hard to get that object to move. Some objects easily overcome their inertia. So we have a softball here, and it says that softball is going to stay at rest unless an outside force acts upon it. There's nobody kicking it, so I'm going to say it's the wind blows the ball. So the ball starts to roll. So now we've got a few forces acting on it. We've got friction that's acting against it. So we've got rolling friction acting against the ball. We've got gravity. Gravity is a force. Gravity is pulling it down towards the earth. That ball is going to stay in motion until the gravity and the friction become stronger than the ball. Or the force of the gravity and friction outnumber the force of the ball in the forward motion. If it makes it all the way back here, we have a wall that will stop it. That wall is definitely going to exert more force than the wind blowing the ball. Newton's second law of motion says a net force acting on an object causes the object to accelerate in the direction of the force. Oh, excuse me. So, a net force acting on an object, the girl kicking the soccer ball, causes the object, the soccer ball, to accelerate in the direction of the force. So whichever way she kicks the ball, it's going to go. And that's the way it's going to accelerate. Acceleration is determined by the size of the force or how hard she kicks it and the mass of the object. How much did that ball weigh? So a little science joke we like to have is when you calculate net force, you're going to use mass times acceleration. So a lot of science people, instead of saying like may the force, when they hear may the force be with you with like Star Wars, I think it is, this is what comes to mind. So may the force equals mass times acceleration be with you. So that's what force is. Force is mass times acceleration. So if you have more mass, you have more force. If you have more acceleration, you have more force. This has a lot to do, and if you play football, you're calculating this in your head without actually calculating your net forces. If you're tall and skinny, and you're trying to knock down a really, really, really big fat person, you know you're going to have to go faster to hit him. Mentally, you just figured out this problem. You did the math for this mentally and came up with an answer. So let's add some numbers to it. We push a wagon that has a mass of 12 kilograms. If the force on the wagon is 6 newtons south, what is the wagon's acceleration? So we plug in what we know. Force equals mass times acceleration. We can rearrange that equation to say acceleration equals force divided by mass. So our mass is 12 kilograms. Our net force is 6 newtons south. We are going to plug it in, and our answer turns out to be 0.5 meters per second squared south. Remember, acceleration's units are always meters per second squared. All right, a helicopter's mass is 4,500 kilograms. The net force on it is 18,000 newtons upward. What is its acceleration? So we're going to rearrange. We have our mass, which is 4,500 kilograms. We have our net force, which is 18,000 newtons up. So we're going to plug in 18,000 newtons up over 4,500 kilograms, and we get 4 meters per second squared upward. All right, a dragster. The net force on a dragster with a mass of 900 kilograms, if its acceleration is 32 meters per second squared. So force equals mass times acceleration. So my force equals my mass of 900 kilograms times my acceleration of 32 meters per second squared. My force is 28,800 newtons west. All right, Newton's third law of motion. For every action or force, there is an equal and opposite reaction. All right, so momentum is the property of moving object resulting from its mass and velocity. How much momentum does it have? If it has more velocity, it has more momentum. And if something has more momentum, it's hard to stop it. So a rocket is a great example of this law. So the action is the explosion, the rocket fuel exploding. The reaction is the upward force. So the downward force equals the force going up. So the law of conservation of momentum says if no external forces act on a group of objects, their total momentum will never change. So in a game of pool, ball A hits ball B. Ball A slows down when it hits ball B, but ball B starts to move. That's because ball A lost its momentum, but it was gained by ball B. So the total momentum before and after is equal. Nothing was lost and nothing was gained. It's equal. It was just shifted around and shared differently. All right, and that's all we have today.